Hey everyone, tonight we're going to go over a review of all the previous topics. We're going to throw out a few things that we don't need, and we're going to gently introduce a couple shortcuts, not too many. Following that, we're going to dive into object oriented programming, which is more of a paradigm than like a feature. It's a way to program using objects as our basic conceptual primitives instead of focusing on procedures. But we're going to unpack that a lot after the review. So what we saw was our programs mostly had this format. We have the global scope, we define our classes and functions. If we have callbacks, we have to figure out where they're going to go and how to handle them. We have our setup and draw functions with appropriate procedures in each of them. We have optional input and output, such as from the user to an image, JSON from an external site, again, using callbacks. All of the input and output is optional except for one thing, the canvas. It would be really silly to have a program that didn't have a canvas. So keep that in mind. With variables, we're using the keyword var. It's short for variable that says make a new variable by this name. Assigning a value to that when you declare a variable is optional, and it depends on the circumstances when you want to do this. The thing about variables is we have to worry about scope. When they're all the way up globally, it can interfere with procedures way down the line, but if it's buried or nested too deep in your curly braces, you might not be able to find or access your variable when you want to. These are some of the reserved variables. We can't name things width or height because p5.js already has something assigned to them. It's kind of a variable, but I want to include array name.length here. I'm including it here because it doesn't have parentheses, so I don't think of .length as a function. I think of it as a property. But I'm putting it here because if you're using arrays, you need the length, and I want you to see this a lot of times. And then we also had center and top, the ones that are in all caps. So objects. When we saw this the first time, we saw this in the context of writing them out by hand in something we called JSON. What we saw later is we can save JSON, we can load JSON, we can even load it from another website using the power of APIs. And the main convention for objects was the dot operator. Now, the Booleans, we spent a lot of time on here, so this is just a really quick review. Basically, we have 7 things that evaluate to false all the time. I'm going to show them to you next. Everything else evaluates to true. So your name will evaluate to true. Any number except 0, true. There's not much to it. Just you have your truth tables. Now you know the things that are always going to evaluate as false. We've seen them, the keyword false, the number 0, empty string. The rest of them we don't care about. I've never seen 0n. Hopefully you're lucky. If you go in, lucky enough to never see it either. Not a number, if you go into data science, you will see that. Null and undefined, those are kind of like bureaucratic bookkeeping values that JavaScript uses behind the scenes. If you never work with them, you can be a great programmer, but if you want to get more into programming, these will pop up. Conditionals. These are kind of like locks. If you have the key, you can get in the door. If you don't have the key, you can't. But there's a little more to them. So if you get inside of an if statement, you're not going to go into the else statement. The converse is true. If you can't get into an if statement and it has an else statement right after it, that's what happens. Can't do a lot with that just yet, but we can chain these to have more conditions. If you're chaining more than a couple conditions at a time, you might want to think about whether conditionals are the best paradigm to use for the decision process you're making. Decision process based programming is a large field. Many of you call it machine learning these days, but conditionals can be abused just like all the other more complicated things. So if you have like 20 if else statements chained in a row, step back, rethink it. That might not be the best way to do it. So loops, what you're doing is you're building a machine with a crank, and every time you're turning the crank, something happens. You want it to happen over and over again, especially if your machine is doing something like printing money or creating a product that you can then sell for money. Loops are the way that computers do work for you. They're machines, so we want machines to run a mechanical process repeatedly. We even have two ways to do it. For loops are much simpler up front. That's not a bad thing. That's a good thing. They're reliable because you're telling them explicitly, stop here, start here, count this many numbers at a time every time you run the code. While loops are much more complicated. They stop on any kind of condition that you can put in programmatic terms. You can make for loops functionally using just the structure of a while loop, but that is very superfluous. One of the main ways while loops are used is you launch an application. That application runs until the user quits or there's a problem that's been encountered. That main loop in that program is just a while loop. You might not think of it that way, but while loops are basically the fundamental drawing block or workspace that all of your programs take place in. We even kind of saw something similar to that with the draw function. I'm not calling the draw function a while loop, but the draw function does run over and over again. Once again, when we nest loops, each layer needs a different name because of scope. If we have two loops that are not nested in each other, we can reuse the same name because of the var keyword. That gives us a new scope every time we're in a loop. But when we nest them, the scope of the top loop will affect all the loops contained inside of it. So keep that in mind. Moving forward, we might also encounter situations where we don't want to talk about I and J in terms of X and Y. We want to talk about columns and rows. If you go into data science, you're going to be caring about columns and rows. You're not going to be caring about width and height. The main reason why I want you to think about naming your loops is being consistent saves you time. You can spend less time thinking about your loops and more time thinking about what goes inside them. Functions. These are our friends. So they're very simple. We need a keyword function that says, I'm defining a function. Optionally, that function can send something back to the program or wherever it called it. We use the return keyword for that. We can combine return with a variable. We can combine it with a fixed value. We can combine it with JSON. We can combine it with objects. But the main part is when we return something, we're just returning one thing. That one thing can be a collection of other things, but it's still one thing. And I had not prepared for this last time, but we did see a function call getting defined inside of the header of get.http. That was called a callback, but the design pattern goes by a lot of names, and we're not going to cover the design pattern. But callbacks are defined sometimes inside function headers because the callback needs to pass through a function first. That accomplishes it. Other than that, functions can live at the global scope in your program, or they can live inside of a class. We call those class functions. Nothing fancy about it. They just live inside of a class. One thing I didn't show you is when you have parameters for your functions, you can give them default values. So here, default value equals true. That just means I can call my new function, slickfunc, without parameters, and it acts as if default parameter was passed in as true. If I pass in false or true, then it treats it as if it had a parameter. So I thought this was really cool. One of the students supposedly, I heard this like fifth hand, so I don't know what they said exactly. One student compared arrays to a train. And I like that a lot. So I use the train emoji, equals, and then arrays. Each of the members of the array is just a capital letter. That tells us these are probably variables because they don't have quotation marks around them, meaning that they would be strings otherwise. Interestingly enough, I think the title for this page is valid JavaScript because emojis are supported, but do not name your variables or anything else an emoji in your homework. I won't like that. I don't think anyone would like that. But emojis in a string are okay. So an array, you can think of it as a line of rail cars. Each one of those cars stores stuff. Like you've got the ones that have like coal in it or logs, or the ones with the sliding doors that have boxes in them. It doesn't matter what's inside the array. What we care about is this car is a compartment or storage place that is discrete. That means it stands independently, but it's also part of a larger thing that we call an array, just like the cars linked together form a train. Now I'm putting links in quotes because there's something else in computer science called a link, and it's very well defined, and this is not what we're talking about. So when we have one car, there's 0 connectors, 2 cars, 1 connector. That rule holds, and that rule is how you number your arrays, or one way to number your arrays. So far, we've seen the very basic variable-esque declaration method for your arrays. Var, array name, equal sign, empty box brackets. Another way, and I want to hear some answers in Twitch, is to create it this way. We're telling the array to start with this many compartments. We can change it later. That is something we call mutable. If it was immutable, we wouldn't be able to add more things. But in JavaScript, these arrays are mutable. That is a really good thing. Be thankful for it. Don't waste your time wondering why it's a good thing. So we give it the name of the array, equal sign, new array with a capital A, and then in parentheses, we say how many elements are in the length, are in the array. It's not a -1 thing, it's the actual number. If you have 8 elements, you put 8, not 7, not 9. So my question is, are we calling a class constructor? If so, for what class? Okay. Yeah, we saw this design pattern with classes when we made a new instance of a class that we defined ourselves. And this almost looks like JavaScript comes with a class called array. We know it might be a class because it starts with a capital letter. And we use the new keyword. Most importantly, we use the new keyword. So we could think of it almost as if we're calling an instance of the array and we're passing the length to its constructor. That's a way to look at it. I want you to start thinking about objects obliquely and kind of like think of it this way. JavaScript lets you treat almost everything as if it was an object. And we don't know what objects are. It's a very vague concept. But we do know that we can call properties from JSON. We can create new instances using the new keyword, and we can apply that to arrays. So let's see if we can take this a little further. Now we saw that this is the classic standard, like no fail manual way to put things in an array. We just say my array equals, and then in box brackets, we just put what's in the array. We see 4 elements, it has length of 4. This is terribly boring. What I like is having loops do array population for me. So I kind of mentioned this before. that with your indexes for your loops, you want to handle it with ijk, but for your shapes, you want to pass over everything to x and y terms. So one way to do this is to have an array of your x values and a scale 33. So when I is 1, x is 33, and then it's 66, 99, and so on. I call this rescaling, or refactoring is a bad term, or conversion is a good term. It depends on kind of like the field you're in. But what you're doing is you're saying, my index is based on I, my shape is based on X. This is the relationship between those two numbers. And it makes your code more readable. Now, the first way to read from array is really boring, but it's kind of no fail. As long as there's something in position 4, we can print out what's over there. If there's nothing in position 4, we have undetermined behavior. It might cause an error. It might read off something else in memory. Let's just assume it's a bad place. We don't go out of bounds of an array. We're polite with it. But if we use a loop, we don't have to worry about bounds, because we know that arrays start at 0 and they end one element before length. So I would be strictly less than the length when we're iterating over that loop, or over that index. So here we can print each item in this way. All that said, if you want to add something very quickly to the end of an array, you use this 2-part function append. The first part is the name of the array. The second part is the thing you're adding. That can be a string, it can be another array, it could be an instance, it can be a number, but it's a thing that you're adding to an existing array at the end. If you want to quickly access the array, your choices are the first element, 0, or the very last element. And I had to break my rule and use -1 here, because this is the only way to directly get the last element from the array without relying on stuff that I'm not going to show you, which was a really bad justification. But what I mean is I try to avoid length -1 and use .length instead. When I'm doing this kind of box bracket access, I have to use -1. So I kind of have hinted at this, but arrays can contain almost anything you want. I'm not sure if you can define a function in an array, but if there's any programming language that you could do that in, I would bet that JavaScript would let you do it. So a 2D array, I think of this in terms of chess. I love chess. It's a great international sport. It's an actual sport. The Olympic Commission recognized it as a sport. So at 0, 0, I'm guessing that's the top left corner if I'm facing the board. I know that each of the 4 corners has a rook or a castle. So 0, 0 is going to have this ASCII character for castle. That's great, but it seems like a lot of work to do the whole board. So if I wanted to iteratively populate this, I could pass my 2D array and combine it with my class-based programming, like a chess piece class, and then give each piece of each board its own piece. This is kind of like a hand-wringy solution. Like, this is not actual code I would drop in. This is just something to think about. This is something you can use, though. If I wanted to draw my chessboard, I can iteratively make an array of a fixed size, and each member will also be, or each element will also be, an array of a fixed size. And then I can call it without parameters, because I had default parameters set in my function header, because I know that a chessboard is 8 by 8. So again, what I'm doing is I'm assuming that somewhere else our board or array board has been defined, like with an empty square bracket. But what I'm doing is I'm updating the variable, the name of the array, to be a new array. I'm calling the constructor. We don't know yet if it's actually happening, but we're acting as if we're calling the instance of the class array. We're calling it with 8 columns. We've already established that it's going to get 8 because it's a predefined header value for the parameter. And then for each of those 8 columns, we're going to add another array at that position, and it's going to have 8 rows. So we're going to receive 8 as our parameter because we have default parameters. And then we're going to return the whole array, and it's going to be attached to some other variable that keeps track of it. And that's this. If we want to do anything with our chessboard, we need my board to be in the program. Sometimes people will just draw my chessboard and wonder why they can't control anything or why nothing's drawing. You need to have control of your variables and your arrays and your class instances. And to do that effectively, you want to have your variables, your arrays, and your class instances, or an array containing those class instances declared globally. So I'm not going to spend a lot of time on input and output because we had a lecture last week on it. But we want to get creative. We can combine input with Booleans, conditionals, other things. But these are like building blocks, and we want them to support objects. So another note, I don't feel like I went enough into callbacks last time. JavaScript has always been focused on web development rather than like high performance computing. But ironically, it's web development and internet stuff that requires like asynchronous, multiprocessing, really advanced procedures, because we can't instantly obtain information remotely on the internet. We have to wait for it to come back to us. And it comes back to us as callbacks. The asynchronous and multiprocessing features of JavaScript are surprisingly robust, and you get introduced to things that may take years to get to in other languages. Like I don't know how to do callbacks in C++, but we can do it in 6 weeks or less in JavaScript. I think that's cool. So APIs, they're almost always built on structured data formats. JSON is the main one we care about, but XML and CSV are other ones. CSV is basically an Excel spreadsheet in a text document form. XML is basically a bigger, more generalized version of HTML. Now, I say structured data. Just because something is in a file on a computer doesn't mean it's structured. It might be data, but it's not structured data. My recommendation is if you encounter data that someone needs you to process for a job and it has no sensible structure to it, it's just, let's say it's just logs of people typing, I suggest not bothering with it. Go for things that are structured because JSON does the heavy lifting for you for free. So I was thinking about this, and every time we initiate a callback, loading something over an API from another website, we're asking them to use electricity, use their internet bandwidth, and a lot of other things. If we bombard a website, it will cost them money eventually. So one thing we can do with the tools I showed in last lecture is we can load from an API and save that into a JSON file and keep it in our replit and then just load from that. I recommend doing that just as a consideration thing, but if you don't know how to do it or if it seems like a lot of work, don't worry about it just yet. But now that you know how callbacks work, if you run up a huge bill on someone else's website, they can sue you. It happens to people a lot. Even though the people that ran the API allow the public to access it, they can get very mad if people use too much of their bandwidth and resources and electricity. Just keep that in mind. So I came up with some debugging tips after seeing some homeworks and doing the office hours. I think by far the biggest hitch people encounter is scope. Sometimes you have a variable and you reuse it and you didn't mean to, but scope got in the way. So just be careful with scope. Use good variable names. Be descriptive about it being a variable in the first place. Um, what object or function that variable supports is another good piece of information. Um, and tying into variable names is, arrays being off by one. It's usually happens when you set up an array too quickly and your loop doesn't match it. So remember, they start at 0, they go strictly less than, not weakly less than. That means it stops one before the length of the array, not at the array length. So conditionals are a great way for error checking. I had a screenshot of me trying to pay my property taxes, and as a joke, I put negative $9 billion in, and it actually let me check out. I don't think the city would pay me that money. I probably would get arrested, but error checking. If you don't want negative numbers, don't let them put negative numbers. Error checking is a huge problem for JavaScript. You have a website, you have a database. I can put database commands in the text field for your username, and I can erase your entire database with it. I've done this for class. This is something that I could get arrested for if I'm not doing it as part of my job, but people do this for fun. So just remember, error checking is super important. And yeah, it's called a SQL injection. And it basically, someone had a text box for user input. They allowed anything to go in there, and it messes up everything because JavaScript is a front end language. In the back end, we have stuff that's valuable. JavaScript lets us put anything in there. And if we don't check it, that will go all the way to the back end. So, lastly, I can't say this enough. Globally define arrays, variables, instances if it's appropriate. If you're in doubt, put everything global. It will make a mess of your loops if you have a lot of parallel loops. So there's no one size fits all solution. Functions have to have parentheses. I've seen people try to call functions without parentheses at NYU, Tandon School of Engineering. I don't want to see it here. So if it's a function that's in a class, you have to use the dot notation and the parentheses. So with numeric sub-elements, such as what we find in arrays and sometimes in API calls will return JSON that has box brackets. These are for things that have numerically ordered sub-elements. An array, that's the perfect example. If it has a named sub-property, you use the dot notation. And as we saw in the APIs, we can combine the two. If there's a sub-property that has numeric sub-elements. And lastly, I see this bug a lot, and this is more of a learning point. We're doing graphics in 2D, and we don't have concepts from more advanced mathematics, so we need to have two separate variables at the least for X and Y. We can't say the speed is 5 and the angle it's going is this. We have to say X is going in this direction, Y is going in this direction. Cool. I'm gonna take a little breather. Is there anything anyone wanted to ask in Twitch? Cool. Yeah, everything in this class I want you to try, but please don't try SQL injections unless you're 8 years old, and then they'll just come and give you a warning and not arrest you. But don't do it. You can get in trouble. So we're going to do something called object-oriented programming. And I know a couple of you will say, well, didn't we cover objects when we did JSON? And we already saw objects. What's the deal? Object-oriented programming is a paradigm and not something you wouldn't say JavaScript is a programming language that you can only do object-oriented programming in. What you would do is say, JavaScript allows object-oriented programming because it comes with the tools for it. There are some languages that do not have object orientation at all, and there are some languages, I think the most famous of which is R, which is an open source language for statistics. It has over 5 different object-oriented programming systems built in, and no one uses any of them because it's a language for statistics and data science. So they don't need object orientation. But we do because we're doing graphical programming. Object orientation is what makes graphical programming, whether it's games, drawing a window on screen, creating a web page, that's what makes those things are made possible because of object-oriented programming. So this is where we're going to reintroduce classes, because object orientation relies on the concept of class and and their instances in order for us to build more complicated classes. There's a lot we can say about this. So this is going to be very, very entry level. We're not going to worry about anything esoteric. So as we remember, we have the class keyword, we have this, which we use with the dot operator, and we have the constructor, which I like to think of it as a special function. Some people are going to say, no, it's not a function, it's a constructor. I don't talk to people who have like weird, like constructors aren't functions views, but like they don't work exactly like other functions. The main reason is we have to use the new keyword in conjunction with the constructor. We didn't have to use the new keyword with the other kinds of functions we saw. So that's why I call it special. So class instantiations. Again, we use the keyword new. We instantiate classes with var, my instance. We can try to make class instances without declaring them without declaring a variable name, but then we can't access them, and so we made them for no reason at all. So please declare them this way, unless you find a shortcut. So the constructor takes the parameters that are passed to the class name and basically assigns them to the internal versions of those properties, which have this dot and then a name. I try to keep my names for the parameters and my internal properties the same, so writing them is easy. Another thing is anything can go in the constructor. So I can put this dot name equals Fluffy, and it's not passed in by the parameter, but it's set by the constructor. So in the constructor, you have 2 types of properties. One are passed from inside, the others are internal parameter or internal properties that you're setting. You're going to see that in code, so don't worry about what that means just yet. And the last and most important thing about class instantiations is we can append these to an array. An append, as we saw, is just adding something at the very end because it's a rail car. So in plain English, or as plain English as I can make this, when we call this statement, we're telling JavaScript, I need an object to be made according to my class definition. Send the values of X, Y, and Z as parameters to the class definition's constructor. Create a new instance of my class with its properties assigned to the values of X, Y, Z. And then we're going to name it my instance. That's it. We can add other stuff to the constructor, but as we've seen it, this is what happens. So far, this is more of a review than anything new. What we're going to introduce in the rest of the slides and the examples I'm going to show you is going to be a little new, but we're just gradually adding a few more concepts to the pot, not new commands. So objects, like I said, these are really nebulously defined. In JavaScript, almost everything can be treated like an object, even if it isn't. Remember console.log? Console.log implies that we have an object called the console. The dot implies that it has a function living there, and log implies that that's the name of that function. So we've seen this kind of taking a basic thing and adding functions to it and then calling them in this way. We just haven't really given a name for the overall activity or the attitude we've had. So let's remember when we introduced functions and we didn't talk about the functions as like a procedural apparatus. We talked about normal stuff just in terms of how they function, their functionality. We've already seen classes and we already know that these combine properties with functions. And we can instantiate many copies of them using the new keyword. But my question is, what if we wanted to go further? Like, what other features could we add to classes and their instantiations if we wanted to make them a little more powerful? Like, what are features that you wish you had while you're doing your homework, but you didn't have yet? I want to hear anything, any ideas in chat, in Twitch. Because for me, autofill. Okay, that's what I'm getting my PhD in. If I had a house and I had a dog, I would want to be able to, let the dog in the house. I'd want my two objects to know about each other. I'd want them to interact with each other. And I'd want like to combine them. Like if I had a dog and if I had like a dog house, I'd want concepts from the house and the dog to combine into the dog house. And, that's not how we make dog houses in real life. So we have to think about grafting parts, like individual parts. And we have to just determine, are these parts, do they make up a thing and can they be on their own? Like a foot or a tail. We don't see tails by themselves. We don't see feet by themselves. They're parts of a dog. But if we had a pack of dogs that's made up of individual dogs, each one of those can be on its own. So object-oriented programming involves thinking about and making decisions based on how things are put together and how they interact with each other. So these are, this is me just thinking aloud, but the owner of a dog or a pet in general is a person. That means in JavaScript terms, in OOP terms, we have a class called person with some other properties, some other functions. Dogs, we want to say dogs can bark. They have a tail, but cats don't bark, they meow. So we have to think of like, what is it we're trying to represent? We can't represent like every single property and feature when we create programs. We have to decide on our own how we want to model the real world. And that's not going to be entirely accurate. There's going to be things we leave out. So we're going to go into some code samples. I want to wrap this up with some advice and some general guidelines. Writing OP code is extremely daunting. I joke that people get to arrays or to data structures and quit computer science completely. OOP is one of those things that if you're introduced to it in the wrong circumstance, it looks much more difficult than it really is. All we're doing is we're adding constructors, a special kind of function, and we're adding curly braces. And if we've taken due diligence to divide up our code into procedures and properties, like our shapes and colors and so forth, we can roll these into classes very quickly. So this is kind of like my step-by-step guide. And if you were paying attention to a couple labs ago, this is exactly what we did for another lab. I gave you code. We changed it to be we changed it into functions. Then we changed that one more time into classes. It's the same thing, except once you've rolled everything up into a class, start adding more properties, start adding more functions. That way, you're not dealing with a whole lot at once. So you're starting at the bottom with a procedure and some properties. You move up a level into functions. You move up another level into a class which has those functions and properties. And then you start adding more functions and more properties at the top. It becomes a lot more easy when you divide it up that way. But the only way to get good at this is to practice it. I've never met anyone who's like automatically really good at object-oriented programming, but people came up with this on their own. Object-oriented programming, it wasn't really a viable idea until, like, vaguely speaking, until like the early 80s. For a long time, this was not a concept in computer science. But if you read up about computer history, what happened in the early 80s was computers went from being business devices to being household appliances. So I think object-oriented programming, for all that it can frustrate you, is a very valuable thing to learn. Unless you go to data science, then you don't need it. So if you absolutely hate object-oriented programming, data science is still an option. So here's some code that I found. This one is going to be adapted into the lab. These are all available as links in the slides. So study them, learn from them, or reject them and come up with something better. But it's there. This is another one. This incorporates some very simplistic user input. This uses a trig function, and last lab we covered optional trig functions. Again, trig functions are optional. I'll explain them to you as best as I can, but if you don't know how to use them, you don't know how to use them. And if you do know how to use them, you know how to use them. But they're there. I consider them animation tricks and not programming tricks, so that's why I don't care if you know them or not. And then this one is interesting because we have one class, egg, the purple eggs. We've got the teal rings here. And then we have a third class, and all that class does is it makes a new ring and a new egg and tells them to start doing their things. I like this because we're not using anything advanced. We have two very simple classes, and we make a third class using them. And that third class is basically how the program controls the other two classes. I think this is a very reasonable introduction to object-oriented programming, is to not worry about like hierarchies like owner and dog, or pet and dog, or pet and cat and dog. Like, those are much more complicated and require ideas about generalizing a concept, and we don't care about that. What we care about is programming and reusing code. We reused code with functions, and we can reuse code with classes, and object orientation is how we accomplish that. So I'm very sad to say that object orientation is a very big field. So there's a ton of things that are really cool to me that I can't teach you in just an hour or even just a year. But we've got the lab, so I hope some of the things that we've taught we can work on once we come back from the break. That's all I got.